Okay, recall the exercise we did here with the lined paper to verify the experimental properties of the fundamental theorem of similarity. In this example, it was easy for us to see that the triangles were similar because one was the dilation of the other, okay, by a scale factor. It was also easy to compare the size of the corresponding angles because we know, because we could use what we know about parallel lines cut by a transversal. So these are parallel lines. Here's my transversal. We knew that these angles were corresponding angles where the dots are, so they're the same angle measure. Okay, our goal today is to show that we can say any two triangles are equal, with equal angles are similar. It is what we call the angle-angle criterion for similarity. The theorem states that two triangles with two pairs of equal angles are similar. Okay, and we're going to start with that, and I want you guys to write that down. Okay, so on Module 3, Lesson 10, angle-angle criteria for similarity, or AA, just says that two triangles with two pairs of equal angles are similar. Now, we only used two A's, AA. Why do you think we didn't use angle, angle, angle? If we know two of the angles, then we should be able to figure the third angle because of the triangle sums theorem. And that just says that the sum of the angles in a triangle equals 180 degrees. So, if we know two angles, say we know angle A here and A prime, and we know B and B prime, we can add those together, A and B together, and subtract it from 180 to get C. And we can do the same thing for A prime and B prime, add them together, subtract it from 180 to get C prime. What other property of similar triangles, what other property do similar triangles have besides equal angles? Okay, the other property is that the corresponding sides are in proportion to each other. So, B prime is in proportion to B, and C prime is in proportion to, A prime B prime is in proportion to AB, and A prime C prime is in proportion to AC. They have the same scale factor, and they've been dilated by the same, so they're proportional to one another. Do you think that it is enough to say that two triangles are similar just by comparing two pairs of corresponding angles? I want you to write down what you think. Do you think it would be enough information to verify that two triangles are similar just if you have two corresponding angles? 10 seconds, write it down. Okay, so now we're going to jump into our examples and look at them. So in exercises 1 and 2, it says draw a pair of triangles with two pairs of equal angles and then measure them and all that stuff. To save time, I'm going to provide you with the triangles. So what I want you to do is I want you to hit pause and I want you to draw these triangles for number 1. Okay? After you've drawn them, then you'll come back and finish the video. Okay? So what we're going to do is we're going to look at this. Okay? If this angle is 90 and this one is 54, and this angle is 90 and this one is 54, okay, then that means that the opposite angles are going to both be 36. Okay? So they have all the same angle measures. Now we want to make sure that their corresponding sides are equal in ratio. So what I'm going to do, is I'm going to use the small one. No, I'm going to use the image, which would be the prime. And I'm going to compare sides. So I'm going to compare A prime, B prime to AB. And I'm going to compare B prime, C prime to BC. And I'm going to compare C prime, A prime to CA. So A prime, B prime is 9. AB down here is 3. B prime, C prime is 15. BC is 5. C prime, A prime is 12. CA is 4. Now, if we do division, 9 divided by 3 is 3. 15 divided by 5 is 3. 12 divided by 4 is 3. So they're all in proportion to one another. These simplify to be the same. Okay? So now we're going to look at number 2. Again, on number 2, I'm going to give you the triangle. So I want you to pause the video and draw both of the triangles, and then we will look at the angle measures and the sides. So on here, when we do this, okay, we have the same angle measures: 114, 45, 21, 114, 45, 21. So we have all the same angle measures, and now we want to compare the sides. So when we're looking at this, you have to know which sides correspond, because this does not tell you. So C corresponds with F, E corresponds with B, and I see that because this is the shorter side and this is the shorter side. So A corresponds with D, and I kind of went backwards there. So what we're going to look at, I'm going to trade this one. B corresponds with E. So I'm going to trade them, change them around a little bit, and I'm going to do it just like I did here. So I'm going to look at the small one. I'm going to put the smaller triangle on the top. So DE corresponds with AB. EF corresponds with BC, and FD corresponds with CA. So here we go. Side DE is 2.1. Side AB is 4.2. EF is 1. BC is 2. FD is 3. And CA is 6. If we simplify this one, we'd get 1/2. If we simplify this one, we'd get 1/2. So they are all in proportion to each other. So, in these two examples, we had similar triangles. So, we're going to develop an understanding to continue to generate two pairs of equal angles, and then generalize angle-angle criterion. So what we need to do now is informally prove why this is happening, even though these two triangles were different, okay, with different angles and different measures. So we're going to begin with a special case, okay, and I'm going to go back to this triangle here, and I want you to draw this in on your paper, okay? So go ahead and draw that in. In this case, we're given the triangle, or the angle, A prime, B prime, C prime is equal to angle ABC, and that angle A prime, or B prime, A prime, C prime is equal to angle BAC. So that just is saying that A prime, B prime, C prime, which is right here, is equal to ABC, which is right here. It is also saying that angle B prime, A prime, C prime is equal to BAC, which is in the same location. So this angle is equal to itself, and this angle is equal to this angle right here. And we can mark that by angle measures, or arc marks like that. Okay, so we know these two are equal, and this one is equal to itself. Okay. So the fact that angle A prime, B prime, C prime is equal to ABC implies that these two lines are parallel, which on my paper they're on the grid line, so that works out. Okay. Because of corresponding angles of two lines cut by a transversal are equal when the lines are parallel. Now, if we let the scale factor R, okay, equal A B prime over A B. Okay, so now we're just going to count. Okay, so the distance from A to B prime is 1, 2, 3. And the distance from A to B is 3, 4, 5. So that would be our scale factor. Okay. And we can do this because of the definition of a dilation. We can find this out. So what we're going to do is write a paraphrase or summary for this. So here we go. This is a little bit long and no fun to write, but we need to know this. Okay? So we are given that the corresponding angles, angle A prime, B prime, C prime, and angle ABC, these two right here, are equal in measure. Everybody agree with that? They're parallel, or they're corresponding angles of parallel lines. Okay? Okay, so corresponding angles of parallel lines. Because of that, we know that line BC and line B prime, C prime are parallel. Okay. We can say that the distance from A to B prime is equal to the distance.
Please excuse the interruption. Just a reminder, Friday morning there'll be an NJHS meeting at 7:20 in the library. Also, any students wanting to attend the state cross-country meet need to see Mr. Popejoy and pay in room 100 by Thursday afternoon. Also, if you have any drama money, you need to take that drama money to Miss Summers at this time.
So, the distance from A to B prime is equal to the distance from A to B multiplied by a scale factor. So just the definition of a dilation, the distance from A to B prime equals a scale factor times the distance from A to B. Okay. With a center of A. We always have to identify the center. Sorry for not identifying that. Previously, when we dilated on a coordinate plane, we knew that C prime would have to go here because it would go up the line, and C would have to go here because it would go up the line and follow the ray. Okay? Because of the same scale factors. Okay, so we're going to jump into some examples to determine if some things are similar and present an informal argument. So you want to make sure that you're able to do this with us. Okay, so these two angles are the same angle measure, 80 and 25. So because they have the same angle measure, they are similar. So yes, triangle ABC is similar to triangle A prime, B prime, C prime, because they have two pairs of corresponding angles that are equal in measure. Okay, so that just means angle B equals angle B prime, which is 80 degrees, and angle C equals angle C prime, which is 25 degrees. Okay, our next one, we have two triangles. Angle C is 32 degrees and C prime is 28 degrees. Angle B is 53 degrees and angle B prime is 80 degrees. They do not have the same angle measures, so no triangle ABC is not similar to triangle A prime, B prime, C prime, because they do not have two pairs of corresponding angles equal in measure. Okay, that would be your informal argument. Down here, we have triangle ABC and triangle A prime, B prime, C prime. Angle B is 88 degrees. Angle C is 48 degrees. C prime is 48 degrees. So we're not given B here or A here, so we have to find the missing angle measure first. So you could take one set, 88, 48, 6, carry the 1, 8, 12, 13, 136 degrees, which is those two. So to find this one, you take 180 minus 136, 44 degrees, so 44 degrees would go here. So angle A and A prime are the same angle measure. So yes, triangle ABC is similar to triangle A prime, B prime, C prime because they have two pairs of corresponding angles equal in measure. And that is angle B equals angle B. I'm going to do this one. Angle A. Whoop. Angle A equals angle A prime, which is 44 degrees. Angle C equals angle C prime, which is 48 degrees. Alright, so now what we're going to do is jump into the exercises here. 3, 4, and 5, and actually I'm going to have you do those 3, 4, and 5 on your own, and then show me your answers, your informal arguments, before you move on to the problem set.